Okay guys, in this video we're going to be kind of practicing our technique to go from rectangular form of a coordinate point to the polar form of a coordinate point, which actually you would think would be the exact reverse problem that we had in the last video where we did polar to rectangular, but it's something that's completely new but still related to the right triangle situation. So we are going to start with generalizing this idea and then using that general idea to just say for points in general, how would this look? So given a point here, the idea is going to be that this time we're actually given the rectangular form of the point. So I'm going to say rectangular here. But we're given the x and y part, which means if I'm drawn on my picture here, means that I know these two values here. And so I'm going to say that I know x and I know y, and my goal is to have this in polar form. And so what do we want to know in polar? Well, what I want to know are two things. As a matter of fact, I want to know the length of this line segment that connects my point back to the pole or the origin here, but I also want to know the direction angle. And so we're going to look at these independently from one another, but the very first part we're going to start by looking at is just the length of r, and the reason why we want to look at it first is because it just relies upon a simple fact, and that is to say that if we know x and we know y, we can always find the hypotenuse for this r value by using Pythagoras here. And so we're going to say to find r, finding r, we're going to use Pythagoras here. Let me switch my P here, Pythagoras. And so I'm going to start by saying that it is true that x squared plus y squared equals, I'm going to write r squared here. And I put r in red just to indicate that, see, that's the thing I don't know. And so because that's the thing we don't know, and we do know x squared and y squared, I'm just going to go ahead and say that it is fair to say that r is always the square root of x squared plus y squared. I'm going to throw a box around this and say you should not lose this. Now, one thing I do want to mention about r is this: r is always positive. So remember that when we talk about this distance back to the origin there, in this case we're going to say r is positive when we talk about the definition of r. Now, in terms of finding the direction angle, now this would be a little bit different, and the reason why is because we're going to have to relate the sides of our right triangle that we know, which are the x and y parts, to this angle. So finding theta, or the direction angle, what we're going to write down here is that if I want this direction angle, then what I'm going to have to acknowledge is if I know x and y, then I'm going to have to find theta by setting up this tangent ratio. And that is to say that the tangent of this angle is opposite over adjacent, or y over x. And so because we know y and x and we don't know theta, this is going to allow us to work backwards by doing a tangent inverse of both sides here. So tan inverse of our vertical over horizontal component here, this is going to be our theta, and you'll notice that I wrote theta prime. And so the thing that I want to indicate here is that when we do this on a calculator, when we do this, what we're going to be getting back is actually the angle that it's making with the x-axis, which doesn't always imply that that's the actual direction angle. Because remember that direction angles always start on the positive x-axis and rotate counterclockwise or clockwise from there. So that is to say, what if I had a point xy that terminates in the second quadrant? I say this is x and this is y. And I want this to be in polar form. Well, knowing x and y, let me go ahead and put these in again. X and y, the things we don't know are theta. See, here's my theta going from the positive x-axis. And then we don't know r. And so when you do, and this will happen, when we use our tangent inverse to solve for theta, we're going to acknowledge that what we're really finding is this part right here. And in this case, if I was doing something like this, if I wanted to find actual theta, I would say that'd be 180 degrees minus the reference angle there in order to get its measurement. So let's go ahead and try to put both of these boxes to use here. And let's see, in red, these two boxes are the boxes we need. If you want to go from xy to theta r, or r theta, then we have to use these two properties right here. And so, taking a look at number 41 here, 41, this is kind of a convenient example just because look where we're at. We're in the second quadrant here. So we go left 2 and up 2, and I think I'm going to switch away from this blue color here. At least let's make it lighter. There we go. So we're going to go left 2 and up 2. I can see it better already. But I do want you to go ahead and draw your right triangle situation. So the two parts of the triangle we are going to label are the two parts we know here, -2 and +2 there. The two parts we don't know, however, are r, and we don't know theta. So I'm always going to say start with r first. So in this case, if we want to find r, Remember that r is defined as, and I'm using this right over here, being the hypotenuse length in this right triangle. And so we could just use Pythagoras. Now I'm going to use the shortcut version of this formula, but if we square our x and we square our y, and we add those together and take the square root, what we end up with here is the square root of 4 plus 4, which is really the square root of 8. So I'm going to throw a box around that. I do want you to know that that is the exact value of the distance away from the origin. But in this case, we do need to reduce this because I recognize that 4, or a perfect square, is a factor of 8. In this case, it's 4. And so the square root of 4 in this case is a 2. So we get 2 root 2, and I'll throw a final box around that. So this is like super important that we get this part right here. And then this is like the best when you get this right here. So get the important part first. Get this part first. Now, in terms of the direction angle. Now we know that the tangent of this angle here has to be our y over our x. And so that's what I'm going to write here. I know my y value of my point is 2. I can look right at my point and see this. And my x value is negative 2. So in this case, I am going to clean this up just because I can. But I get the tangent of our angle is equal to negative 1. And so to solve for this angle here, I'm going to do theta prime, or the reference angle, is the tangent inverse of negative 1. Now here's the deal. Where does tangent equal negative 1 at? This is where I'm going to pull out my calculator. I'm going to say, hey, dear calculator, what is the tangent inverse of negative 1? And so something interesting that's going to happen here is going to tell me negative 45. And I want you to understand something, that all I care about is that it's making a 45-degree angle. And so ignore the negative. When you look at this picture here, though, and I'm going to switch to let's do a green. What we just found, you guys, was this inner reference angle that it's making with the positive, or with the x-axis, excuse me. So in terms of what this is here, we're going to have to say that it's equal to 180 degrees in this case, minus 45 degrees, which means that this is a 135-degree direction angle. And so this is why it's going to be important that you draw the picture, just because this inner angle is always going to be acute. It's going to be an angle between 0 and 90, but if you do not lie in the first quadrant, then you're going to be an angle that is greater than 90 or less than, say, 0. So if that's the case, draw your picture. So last but not least, we're going to say that if this is my point in rectangular, then my r theta format would be 2 root 2, and we're going in a 135-degree direction. So going from rectangular to polar, use your x and y to find r, Pythagoras, and then do tan inverse of y over x to get your reference angle, but at least use a reference angle to work backwards on your picture to find out what would your actual direction angle be if you were to leave from the positive x-axis. Cheers.